geometry people that are not here. But now we're doing something new. We're moving on to lesson 10. Conditional statements. What are they? How do we use them? Conditional statements. I'm in lesson 10 on page 58. A conditional statement is a statement in the form if P, then Q. Where P is a hypothesis and Q is your conclusion. And you're thinking, this is not a lot of geometry. This is like a logic class. Somewhere you've seen lots of conditional statements. Sometimes we call them if-then statements. If this, then this. Where have you seen some of those? Science. Where else?
Oh, yes. Oh, hypothesis.
Logic. Where else do you see these? Now math. Have you written any down? What do we call them? Say it louder. Theorems. If two lines are parallel to the same line, then they will be parallel to each other. Okay? You've written down lots of theorems. Not every single theorem is a conditional statement. Not every single one are if-then. Okay? And there will be a couple conditional statements that won't have an if and a then, but they'll still be conditional statements. So most all are if and then. Okay? Do you see these conditional statements anywhere else? Maybe not in school?
Politics.
Okay. Okay. If I do this, then this will happen. Oh, punishments. Let's not think of punishments, but it definitely is that. A warning.
Oh, that's so different.
Okay. Do you see these warnings in the Bible? If you behave badly, if you do this, this, and this, then something bad will happen. I like the good ones. If you do these good things, if you follow my laws, if you follow my teachings, then good things will happen. Okay? So the hypothesis, we have the word if, and then we have hypothesis. Something that you want, something that's mostly always true. Okay? Then a conclusion. Okay? Then what's going to happen if you had done the first thing. Okay? So let's put up some conditional statements. If it is morning, then the sun is in the east. If it is morning, then the sun is in the east. All right, Paxton, can you please come up here and underline the hypothesis? John, will you come and underline the conclusion and label it with maybe just an H and a C?
Pick your color.
You can pick a color. I picked a red color, but if you want a different color. Oh, that's not labeled. And what is the hypothesis? Morning?
Morning, yes.
That's all the hypothesis is.
If it is morning. Oh, it's labeled.
Okay, so the word then, but not the, is in the conclusion.
Wait, I put then. That's me.
Okay. I'm doing this first just to get the scenario. If hypothesis, then conclusion. So, should the word then, is then part of our conclusion?
No.
No, it's not. Okay? So, but what, oh, that erase is really big. Sorry. Really big. Just want to erase that line. Then should not be part of it. You can go ahead and unlock, but should be?
Yes.
Yes. The. Sorry, I changed the
No,
color.
you're fine.
Sorry. So the hypothesis, if you just need to identify the hypothesis, it's the words after if and before then. Okay? The hypothesis is always, or will never include the word if. It is morning. Then, conclusion. Okay? The words if and then will never be in our hypothesis or conclusion. We also need to talk about truth value. Conditional statements have a thing called truth value. What do you think you're finding when you're finding the truth value? Is it true or is it false? Okay? This conditional statement, is it true or is it false?
It is true.
If the sun rises, it doesn't rise. Everybody knows the sun rises in the east, correct? Rises in the east, sets in the west. That's how I remember. I have to face north to know the sun rises in the east, sets in the west. Maybe you didn't do that. I don't know. If anywhere you are in the world, if the sun is in the east, then it's morning. If it's morning, then the sun is in the east. Okay? So some things you're going to have to know logic to know if they're true or false. But if it says determine its truth value, it wants to know is it true or is it false. Okay? What about if an angle is obtuse? Okay, that's just gonna be one word. Then it measures 120 degrees. All right, Sadie, come underline the hypothesis. I'll let you pick your own color. Riley, come and underline the conclusion. You can pick your own color. Okay. Now, is this a true, what is the truth value of this conditional statement? What are you saying, Jackson?
It's true some of the time.
Okay.
Definitely not all.
Okay, if it can be false anytime, ever, then guess what?
Not true.
It's false. Okay? If it can ever be false, if the conclusion, if we can put something else right here for the conclusion, then it can be false. Okay? It will be false. It has to be false. Okay? So this truth value is false. Because sure, 120 degrees is obtuse, but just because an angle is obtuse doesn't have to measure 120 degrees. And that answer is no. Okay. I'm going to write one more. I probably will write more. If an angle measures 120 degrees, then it is obtuse. All right, Jackson and Lucas, go underline your hypothesis. Yellow.
Of course it's true.
Alright, if an angle measures 120 degrees, then it is obtuse. What is the truth value for this statement? What do you think? What is the truth value now?
True.
It's true. Why?
Because anytime an angle is 120 degrees, then it is obtuse.
It's obtuse. I can't put in anything else right there that would make that be true. Okay, 120 degrees, then it's a right angle. 120 degrees, then it's an acute angle or a straight angle. No. This statement is true. Do you notice something between this statement and this statement? What did I do? I flipped the what?
The last part and the beginning part.
Okay, so what do we call that last part and that beginning part? What are these H's and C's standing for?
Hypothesis.
So I switched the hypothesis and conclusion. There have been a few, meaning several, theorems that have done that. So you read a theorem and you write it down. And sometimes the next one will say the exact same words, but they switch the hypothesis and conclusion. We call that a converse. The converse, really. The converse, and I probably would say of, a conditional statement. The converse of a conditional statement will be written as if Q, then P. Okay, so you have to start with a conditional statement, and then you just switch whatever the hypothesis is for the conclusion. Okay, sometimes, let's see, let's write. If now, I'm going to say it, and you can argue, yes, sometimes a cat might lose a leg, might be amputated, something. But we're going to say, in general, if an animal is a cat, then it has 4 legs. Okay? In general, that's a true statement, correct? The hypothesis is an animal is a cat. So I need to tell you what, to let everybody write. How long time we got here? Can you tell me what the converse of this statement would be? If you want to come right really fast, Joanna, write the converse of this statement.
Oh my gosh, the power. Can I
You
just
want-
like switch it or do I have to?
Do you want a pen? Go. Actually,
This is like
oh,
so weird.
left-handed is not like
Yeah, it's hard.
because you're in your own shadow.
Dang, if an animal.
Oh wait, do you see what she just did? What? No.
She reversed it.
The conclusion and the hypothesis.
Okay, but what does the conclusion say?
It has 4
Did she immediately put it if it has 4 legs? What did she do?
left animal.
What is it? It is
Cat.
an animal. Okay. Okay. So thank you very much.
Sorry.
Then it has 4. Then it is a cat.
Wait, there's a pin for this?
It is.
That's so cool. My handwriting.
All right. Number 1, you were only putting a line under. Okay. Writing a whole sentence and left-handed people have a lot of trouble.
It was so hard. I couldn't see what I was writing.
Yeah.
It was. It's just a special.
Okay. So, the hypothesis and the conclusion, we just switched it. So the conclusion was it has 4 legs. If you're putting that at the beginning, tell me what it is first. Then an animal is a cat. Is the statement statement true? The conditional statement true? I think we said yes. Let's agree. Is its converse automatically true? No. If an animal has 4 legs, then it's a cat. Could be a dog. Could be a cow. Could be a giraffe. Any number of things. An elephant. Okay? Yes.
Why would you switch it?
Why would I put if? Why?
What's the
Because we're going to have lots more things. If this is true, then something else will be true. Okay? We do it a lot in theorems. If I give you this, then this is true. But what happens if I switch it? And sometimes the converse will also be true. And sometimes we can combine them into something even more amazing, which we're not going to talk about today. Okay? This is just the beginning. Okay? Just the beginning of conditional statements. But I need to show you one more. If x squared equals 9. What is the hypothesis? Somebody raise your hand. Or, okay, Margaret Ann, you're the only one who hasn't been up there. Do you want to come and underline both of them? I'll even let you pick your color. I'm very, I want to pick color. And I mean, it's not. Are you underlining if? Yes, the hypothesis, x squared equals 9. The conclusion, x equals 3. Is this, now everything, don't say anything out loud, is this a true or false statement? What is its truth value? Okay, wait. So, the fun thing is when I said don't say anything,
Oh,
I'm
I thought you
That's
said
because he's
is
like,
what's. I thought you said what's the truth.
keep this in your head. What is its truth value? Is it true or is it false?
So false.
Okay, so now, how many people think this is a true statement? How many people think it's a false statement? So, what would make this false? What could? Question is, can I put a different conclusion and it still be true? This is 100% false.
I
100%
told you it was false.
It's so false.
false. If you can put a different conclusion and the hypothesis still be true, it's a false statement. One counter example can make it false. Alright, you may go. We don't have any homework. Have a great rest of your day.